We like to do applied stuff too, but we like to really focus on whatever's coming up that's new, or anything that was seminal, that was really important to getting deep learning to where it is today. This is an open discussion. It's bi-directional. The speakers have a plethora of experience, and so do the people sitting in the chairs here. So if you guys have any thoughts or insights, and especially if you have questions, just raise your hand, and then I'll call you. I'll be sitting back there. And this is the 177th event, so this group's 9 years old. So I want to give a quick shout out. So a year ago in June, we had this event. It was it was for Luminal, it's a company. And at this time, a year ago, this was just like an open source GitHub project, right? And they're good friends of mine, the people who do this company. And in June of this year, they got into YC. They're not, thank you. So they're not in Austin anymore, unfortunately, but they did find a really good spot there, and all their customers are definitely over there, because what this company does is it takes any neural network, if you can put it in an Onyx file, this is my understanding, they can take it as an input, and they will optimize it, so they have an automatic compiler that'll reduce the actual sequence of operations in the graph, so it can run more efficiently, and then they host it for you, and they give you a really nice serverless endpoint. Really cool service. There's a lot of cost measures that are going around, so I think they're very timely. And okay, so they have a job posting, which I did not update that slide. Hold a second. So if you guys are interested in working with them, they're actually hiring. So they're looking for a founding engineer. You would have to move to SF. I know it's a tough decision. But they're a really great company, and all of them, so from the right to the left, it's Matt, it's Jake, and it's Joe. All of them, all three of them met each other here, okay? So, if you want to find a co-founder, this is a really good place to meet someone like that. And if you don't want to find a co-founder, you can find a job. So definitely join this group. It's completely free. Be a member, and by being a member, you just get regular emails whenever we do one of these, so you can be sure to come back. So I'll leave this up for a second. Okay. And with no further ado, I will now move on to Alex's talk. Please welcome Alex.
All right, thank you very much. Excited to be here. My name is Alex Kalish, and we're gonna talk about some grounding, innovation, the things that are in your head with some industry knowledge about what's going on in robotics and connecting with people where they are. So I've spent about a decade at Amazon. Actually, I have spent a decade at Amazon, going from operations floor to learning and talent development. I've led big teams, small teams, like sustainability teams, and every single one of you has seen the results of one of my transformations. It's those 2D barcodes on the shipping label. So I can talk your ear off about why 2D barcodes are better than one-dimensional, which is just lines. Spoiler alert, you cover up one of those lines, can't read the barcode. And when you have millions and billions of packages going out, makes it significantly easier if you can have a barcode that is coverable. I've led a bunch of different transformations from learning and talent development through 2D barcodes and whatnot. Now I'm in charge of training and consultation in the generative AI space inside of Amazon Robotics. So I lead this transformation from people not really going to generative AI or thinking about using it or how it can help, or I'm an engineer, there's no way it can help. And I love those type of people, because by the end of an hour long with me, they're like, oh, that's exciting. And they've got like chills, and they're like, God, come on, let's do this again. So from a generative AI standpoint, I also have a good pulse on where the state of affairs are for just robotic systems and how they use generative AI or AI and machine learning. Just a quick disclaimer, the views that I'm going to talk about are my own. They're not associated with the employer. There's not going to be any confidential information. I'll talk a lot more in generalities. Can't speak on the specifics. That's trade secrets and stuff. I have to get like a bunch of approvals in order to let those out. Okay, so robotics and the AI landscape today. One of the biggest challenges is that there is a lot of fragmentation in tools as well as platforms. And there is a large centralization effort to bring a lot of information under one house and be able to gain benefits from information that's stored in, like, say, the bill of materials, to a engineering document or a diagram, to a project management list and what's going on when. All of those tools have different sources, different APIs, and there's a lot of different tools that are all building AI on top of that. And yes, it might be really good at analyzing that specific realm, but then it misses out on capturing a greater opportunity for robotics development. A lot of different platforms. So you're going to see a couple robot systems. This picture that's up on the screen, those are some of our drive units that we send out in our sortation floors and whatnot. So we have packages, they get packed, they're in boxes, and they're right next to other packages that are going in very different locations. So these robots, they singulate the items, which means that you get one package per robot, and then it drives using a bunch of QR barcodes on the ground. It's not like autonomous driving. It's very rigid, controlled. There's like entire teams that build the science behind where the robots move in order to get there as fast as possible, keep the uptime, a bunch of those KPIs. Okay, so there is a large mismatch in terms of creation of new tools and practical adoption. So what I mean by that is there are hundreds of tools inside Amazon and growing every single day. And they're custom tailored with different instructions, knowledge bases, and they're very good at the task that they were designed to do. And the team that made it is like super excited. They want to roll it out everywhere. They're like, this is the best tool at doing the thing. And so they blast it out. And then other people start coming into that tool, trying it in something that is similar, but not exactly the same, and it breaks, and it sucks. And they're like, this sucks, Gen AI, it's all hype, this is terrible, I can't get any value out of this, it's terrible. Yeah.
So just quick pause, what do you think the success rate is between a perfect solution for that problem versus something that's just close enough?
The percentage.
You can shoot from the hip.
So like what I've found is that like people who are using these tools and getting bad information out, especially in terms of they're asking a specific question and expecting retrieval augmented generation to get them the right answer with that question, and they get the wrong answer because they know what the answer is, that just destroys all trust. Whereas there's a lot more value in thought partnership with some of this generative AI. When you start using it and you start thinking about it in terms not of this is going to get me an answer, but this is a thought partner on how to work through a problem, and you get an 80% solution with that because you're not great at prompting. It's like your fourth prompt ever. Like, tons of value, and people light bulb goes off. So it kind of depends on the use, I guess, is what I'm saying, unfortunately. There is, so practical adoption, and I was talking to a couple people before this. Most people are a couple different themes that I've seen, because I've done thousands of workshops over the past 3 months. I've talked to 100 directors and VPs one-on-one, and there's some general themes. One of them, people think it's cheating. And it's like, like, I get it, like, you were trained from a kid in school that like you have to have it on your brain, and if you get it outside of your brain, then it's failure and you cheated. I get it. You've got years of conditioning like that. But at the same time, when you think of like general technology adoption, like we used to have people that hand wrote all financial information, like pre-Excel. Like picture how much paper, how many issues people like with handwriting, the lack of statistical analysis, because doing the statistical analysis took so much more time. Like you had to write it out and do all, and now it's just like, oh yeah, I made a formula and it does my stats. So there's practical adoption on cheating. Most people don't understand how to get started. They look at the screen and like, I don't know how to use this. I don't know even how to talk to it. I have to learn how to use generative AI, and that causes a big barrier from a leadership perspective. And then a last one is they're very wary of every time they've gotten a wrong answer. That is an adoption killer. And one of the things that like turn people away from it and they turn into like, oh, it's not gonna help me. Those are the people I love. I love getting in a room together. So some of the challenges ahead for startups that I foresee is that there's so many things that people have come to me and been like, hey, would this add value to Amazon Robotics? And I'm like, honestly, 5 years ago, yes. Now, no. We can functionally do what you're saying with off-the-shelf generative AI tools right now. Like, why would we get a system like this? And there's not really a good answer a lot of times. And so when we're talking about getting people like enterprises excited about the things that you're working on or the things that you're thinking about, approach it from a standpoint of there's a lot of enterprisal inertia, and like being able to highlight the actual problem point and the value that you provide is so critical in an era where it's like, well, can't I just do that with ChatGPT? Or can't I just do that with our internal Q business, Q developer? So got to be able to answer that. I would also say that there's a lot of well-intentioned startups that are in the robotic space, and they're like, look at this, we built this thing and it can do it really, really well. And they only do it for books. And books make up a very small percentage of the total sales of Amazon. Can't tell you how much, but it's a small percentage. And if your widget and your robot is only good at doing one specific thing, it's probably not going to have legs inside of an enterprise where there's so much variation between items and the scenarios that that the robot might find itself in, that it becomes unusably bad. One of the big themes that I see inside Amazon is that the value is still where coding changes the physical world. There's a lot of startups that are coming out that are functionally just changing ones and zeros. When you really boil it down, nothing in the physical world is changing unless a person does something. But when we talk about robotics, that's when ones and zeros now turn into motion. And that motion changes the physical world. And that's where value meets the road.
Before you move on, so you said that maybe a company works on with books. How do you kind of stratify this? Is this based on the size of the object or the weight of the object or the type of object? Is it like makeup versus t-shirts? Like,
yeah, I mean, you just have to, it's mind-bogglingly difficult to just capture the amount of variation that's out there. Like picture all the items in this room. There's maybe, I don't know, a couple hundred tops of different items. They're all sold on Amazon or something functionally similar. You get into the millions. Even just picturing a million. Like people are very bad at picturing a million. If you go to one of those like kids science things, they have like an actual million little pellets in a tube and like they're different colors, and you can see it's like, oh, 50% are green. And you can see a bunch of green. 10% are blue. You see some blue. Like 1% are black, and you can barely see any of those. Maybe you get some. There's 100 pink ones. You can't find a single pink one. There's one gold one. Yeah, no way. You spend hours looking at that thing. So actually wrapping your head around the variation of products is vastly difficult. It's a log scale of sales. So when we talk about getting into some math, when we talk about like the top 110 items, 1, 10, 100, 1,000, 10,000 items, they represent a much larger percentage than you would expect of total sales. But the very bottom, the last like millions and millions, still represents a huge percentage of volume. And so, and of those products, there are some that don't have any imagery associated with them in our system. Maybe they were brought on and the camera was down that day for any number of reasons. There's a large percent of items that we don't know what it looks like. Or when I say we, robots don't know what it looks like. And so when you try to apply an ML model to determine what this item is, where its bounding boxes are, like how to pick it up, is it broken, is it the right thing, becomes a lot harder in those fragmented systems without having everything all condensed into one, and it becomes a lot easier if you have images. Now, take all of those millions of items and recognize that a whole bunch of companies well-intentionedly are changing their packaging to be, on theme for the year, or different colored to attract attention, or sustainable. And now all of a sudden, every single image that you have of this item now has to get changed. But there's a period of time where they both exist, and they're under the same thing. So it becomes really challenging computationally and from a robotics standpoint to actually understand that amount of variation. I'm using general numbers, but I'm telling you right now, do a deep research task on how hard this is, ask it to explain it to you like you're 5, and it'll probably do a pretty good job, better than I will. But anyway, robots changing the physical world, super important. Overcreation problem. We got a lot of people inside Amazon that are very well-intentioned builders. It's great. And we got a lot of companies that are out there. I mean, this is just one that I pulled from the web. I don't know how good it is. I didn't zoom in. But you can see that there's a whole bunch of companies. They're all in the AI space. And they all do some things that are slightly different. And this is what's happening inside large enterprises as well, is there are people that are well-intentioned, they're like, this solves my problem really well. And they go and they try and find it, they pilot it, and then it almost invariably stalls out. Because at the end of the day, needing something that solves major business problems is really tough when you're so narrow, or when it requires a significant startup cost. You can't pilot it very quickly to understand, is this solving a problem? Something that is pilotable super quickly, that's very secure and can be kind of removed from the chance of hackers going in and grabbing all of customer data and whatnot. Much more, hey, let's get this off the ground, let's try it. But chances are that one advocate, unless they're able to bring a lot of people on board and understand and drive adoption, and hey, this is a problem across a wide swath of Amazon, it's gonna fail. And we're gonna have too many tools, and they're not enough integrated. They integrated this one component, but then they stalled out. And now it's missing out on that value that I was talking earlier, where it's integration becomes a really hard challenge.
Is there some kind of a sandbox for you guys to test early, methods or models before releasing it to a larger scale?
There's a whole bunch of different testing beds inside of Amazon. It's, again, I'm trying to make sure that you're sitting here for a reason. You're trying to get in, understand how the industry is performing. And one of the big things is there might be sandboxes. There might be well-intentioned people that are like, this sounds great, let me try it. And then it just stalls and it just doesn't go anywhere. And you're so excited and you've bet everything on this Amazon partnership. And it's you got somebody that's really excited about it internally, but they don't have the language to drive adoption across a wide swath of Amazon. They don't have the ability to articulate the pain points to a wide enough audience and why the solution that you provide is so helpful to a wide enough audience. And then it just stalls. And we end up with more and more and more tools that are still like, yeah, someone can use it. And there's certain people that love it and they'll swear by it. But then eventually what's going to happen is some VP is going to be like, why do we have 20 of these? X. Like, stop it. Like, get rid of it, deprecate it tomorrow. Like, I don't want to pay. For good reason. Like, there's too much overlap. Losing users in complexity. That's another, like, when you talk about onboarding a team onto a platform or something like that, it has to be easier than you can imagine, because we have internal teams that are building these agentic systems, and it's like, oh yeah, you just got to onboard with us. You try going through the onboarding documentation and everything like that, and it just keeps failing. And these are teams that have lots of horsepower, and they've got lots of people, lots of finances and whatnot. So now picture that as like an external focus. Like, if your users can't like get onboarded in like hours, minutes tops, like, it's going to be really hard to drive that adoption component. Anyway, like grounded user-centric design. Like, if you're planning something, like, if you think it's easy, make it easier. Like, ask a 5-year-old, can they do it? If the answer is no, it's too hard. Like, make it easier. Okay, so, I mean, this is kind of building on some of the themes from the last one, where we're talking about meeting users where they are, which is like, they have too many tools, why would they pick this one? Especially when you can start going to these enterprise generative AI solutions that functionally can solve a lot of, I've got this great idea. It's like, I could make a prompt that functionally does what you're talking about. With an agentic solution, certainly, and with a non-agentic solution, probably. Practical workflows are significantly better than flashy prototypes. You can make this flashy prototype like a great video and like share it out to everyone, and people are not going to be like super excited about it until you get to practical application. Like, this is a problem, this is how we solved it, it was fast, we got it done, and like, people are seeing the value out of it. Like, you want those light bulb moments from people inside enterprise systems.
Are you able to talk about anything, that seemed kind of boring, but then ended up being a big monumental improvement?
I'll have to think about that and maybe answer that a little bit later, because I don't have anything that immediately pops to mind that I could talk about. I have things.
Are most of the proposals boring or exciting? On face value, at least.
I would say that most proposals are exciting in that, like, they like really capture the attention of like one well-intentioned person or like a leader, and they're like, oh, this looks really cool. And then it gets to like the people that are actually going to use it, and like somebody that pokes into is like, what do you mean it takes me a week to onboard into this? And it's like, you lost everyone. So I feel like I have an example, it's not coming to mind right now. And adoption, it grows from habits, not hype. And this is where I'll preface. Like, so my role now is generative AI transformation inside of Amazon. And what I'll do is I'll do a bunch of workshops with people, and I'll give out these stickers. And these stickers are by far the best way to get into generative AI and get people into it. And it's a visual stop sign that reminds you, whatever you're doing throughout the day, just ask how AI can help. That's it. Like, list 3 ways AI can help me with this email. That's it. Like, you will be blown away. If you do that 5 times a week, you will be blown away by the results that you get. So this belongs right next to the trackpad, and I'll pass them out later. You're welcome to take one. It goes right next to your trackpad, and it's a visual reminder to ask AI first. And that habit forming, that's what drives change. Because you're asking people to do something different than they would have otherwise done. Like, they're used to using Slack to communicate with people. They're used to using email. Now we have Zoom and Teams and Chime and all these different things. And every single one of those causes a adoption curve problem. And so by grounding this in where people are at, it's much more helpful. I know I gotta start go a little bit faster, so let me go a little bit. All right, couple case studies. Adoption in a 3,000 person org. There was a bunch of things that I did. It increased a lot. I can't tell you how much, but like 10s, 20s, 30s of percentage of weekly adopters by like helping people engage and build that habit on a weekly basis. Using Gen AI adoption with like practical playbooks. People are like, give me a prompt library. I'm like, absolutely not. Like, because what's more important is learning how to interface with the tool. Ask AI to craft you a prompt to do the thing. Craft you a prompt to analyze the email. Craft you a prompt to list out different ways to use it. That's what really has resonated with folks.
What's the profile of people who are more reluctant versus more open to adopting these tools? Is it age? Is it their role? Is it?
I think it's mostly frustration.
Okay.
Like, that's what I found to be the biggest thing. People that are super frustrated that they got bad answers. They hear all the hype, and they're like, let me try it. They try it, it fails. They got a bad answer, and they don't recognize that like they're the ones that like caused that wrong answer. So that's one of the biggest lessons learned. And then they don't have somebody walking them through. Like, I can talk your ear off about all the things that it can do, but much more valuable is like, get out your laptops. Let me walk you through how to actually do this right now. Just type in, craft me a prompt. And that's really resonant with people. So it's like people that have kind of just self-starters, great. But the people that are more reluctant have no time and they got bad answers a couple times, and that's it. That's what it takes. And the last thing is that I do a ton of robotics. Like, my last role was in leading a experimentation team in robotics annotations. And what that is like machine learning takes photos or videos of products, and the machine learning is like 95%. But if you got 5% of your orders broken, you would not be an Amazon customer for very long, because that's super frustrating. You would get 1 or 2 items per year or more. And so I guess it depends on how much you order from Amazon. But the point is, like, having annotators that are in the loop, human in the loop annotation has been a cornerstone of helping make sure these robots work super well. Couple quick lessons focusing on usability and easy integration. Like I said, whatever you build, run it through some generative AI and be like, can a 5-year-old do this? If the answer is no, make it easier, make it simpler, make it easier, make it simpler. And if it takes longer than 15 minutes, you've probably already lost people. Bridging hype with measurable outcomes. Highlight the problem and the value that you provide. If you have a custom solution that gets better results than any other generative AI solution out there, gotta be able to show it to me. Like, give me the percent difference. Is this an 80% solution to a 95% solution? Or are we talking, hey, an off-the-shelf tool gets you 95, our tool gets you 97. Just not probably gonna spend the money on it, like, honestly. And you wanna build ecosystems that stick, not just tools. And what I mean by that is communities of practice, like habit forming. I'm already at 25 minutes, so. Anyway, I've been Alex Kalish. You're welcome. That's my contact card. So I actually asked ChatGPT at the AI4 conference. I just took a photo. There was everyone. I was like, how can I use generative AI to help? And it's like, well, there's so many people. You're probably going to want to connect with them. Do you want me to make a phone card that has all of your information in a QR barcode? I was like, yeah. And so, yeah.
So one last question. What's like a good minimal viable ensemble of tasks or people or roles to help move a new project through? Adoption and usage.
I think, so are we talking from like a startup realm, or like trying to take a startup idea and get it inside Amazon?
So I would say anything that was relevant for someone internal to Amazon or someone external selling it to Amazon.
Okay, so for folks that are external trying to sell to Amazon, one of the key things is that you're gonna find people and they're just not gonna have decision-making authority, almost certainly. And so getting a group of people to get excited about something rather than a single person, get someone on the phone, make it so tangible that they're like, you know what, I want to bring in like 5 to 10 more people. Make sure that there's some sort of paper that they can provide to their leadership and get a decision at the end that's like, we want to write you a check.
What do you care about? Generating more profit, more consistency, more reliability, lowering costs?
Yes.
Okay. All right.
Yeah.
All right. Everyone,
Those things.
give it to Alex.
All right. Thanks.
We gotta go one back, one no. Oh no, I started before that. I already messed it up. Hello, everyone. I'm George. I've been coming to this. Yep.
Okay.
Oh yeah, if you want to pull up the paper.
So this one is an actual paper deep dive. So if you want to have the paper open for reference, you're welcome to scan that QR code. I can make this.
It's a pretty short paper. It's a fun one.
It's very short, but if anyone wants to scan that. Take your time, there's no rush. Quick show of hands, who here uses Claude Code, Cursor, Windsurf, any of these things?
Yeah, who vibe codes? Who's
Yeah.
vibe coding these days?
Vibe debugging.
Okay.
All right, looks like most of the people here are.
Most people are.
Okay,
It's a vibe.
right.
It's fun.
no pressure.
Hello, I'm George. I've been coming to this deep learning meetup for a couple of years now. It's been a ton of fun. Learned a lot here, and happy to give back in my own presentation for it. I'll say I'm not an AI researcher. I'm a back-end engineer for Home Depot. I work for a company called BlackLocus, and I use agentic coding, and it's been very interesting this year with all the advances of it, because this didn't happen last year with the agenticness and the reasoning. The paper is called the Debugging Decay Index, Rethinking Debugging Strategies for Code LLMs. And with that, how many people get it stuck where you want it to solve your problem and it failed? It failed, and you try and you go try it, like you failed, try again. And sometimes it works.
Make no mistakes.
Make no mistakes. Do it better this time. And then maybe you try it a third time and it's still just failing, and it's failing, and it's failing, it's failing. If you ever ran into that problem and you've refreshed your whole context and then it worked the next time, well, that's the paper. So it's just on yet another metric. So we don't always get the one-shot solution that we want. We kind of have a debug cycle flow like as people. The paper will present this new metric called Debugging Decay Index to provide a unified assessment of LLM coding proficiencies by modeling the exponential efficiency decay observed in iterative debugging processes. Fun. And it's a nice way of measuring these things, and that's why I think it's cool. Like, why do we need another metric? There's a million benchmarks these days. Everyone's got to be 100% on all these benchmarks. But this one's pretty interesting in that no one's really measuring it, how it performs with, an extra attempt of debugging, of like working with humans, as there was the thought partner that we spoke about briefly. That most of them are used this metric called pass-K. Pass-K, probability that at least one of the K independent general solutions will pass the unit test. So it gets a data set of leak code style like questions. This paper uses human eval, which is leak code style questions. And usually they'll generate a bunch of solutions and see if any of them pass. And then you could say you have pass-K. And the pass-K is nice, it's binary. So it either passes a unit test or it fails one. But it doesn't account for, is it close? Is it very close to the solution? Like, can then a person take it that extra 2%, 5%, 10% to finish it to pass the unit test. So this is their solution to making a better metric. So they have these three research questions. This is the first one. Is the debugging windows. How many debugging attempts maximizes the effectiveness of LLM-generated code before one further iteration yields diminishing returns? And how did these attempt windows vary across different model architectures? So they make this decay function where E of 0 is the initial effectiveness. And the effectiveness is measured by, it's on the human eval data set. There's like 143 problems. Effectiveness is going to be measured by how many problems you solve over the total number of problems. So if you get 8 out of 10 problems, you're at 80% effectiveness. T is the debug attempt, so those are always going to be like integers, 1, 2, 3. And then what they're really trying to solve for is this lambda, is the decay constant. So each model is going to have its own decay constant. And you'll see that you're going to want a low decay constant, because that means that you can kind of work with it more, and you can give it more debug attempts, and it will eventually solve the problem, as opposed to it just falling into the trap of like, it will become, the effectiveness will go to 0, and it'll never solve that problem. And then they give this little half-life formula where they say the half effectiveness, basically. They're going to find the half effectiveness, and then that just goes into a general formula where they say at debug attempt T of theta is when theta is the percent of theta of its like effectiveness. So it's when they say 80, it's really 20% as effective, because it's 100 minus it. So we'll show you later. But this is just them constructing the formula and putting like the framework of this debug window of each attempt. We should be getting more effective, or we'll get less effective at solving the problem. And then the actual experiment itself and the Debugging Decay Index is how we can develop a unified evaluating metric that can comprehensively assess LLM code generation and debug capabilities, quantifying initial performance, sustained effectiveness, and iterative refinement capabilities, encompassing both reasoning proficiency and instruction following competencies across diverse model architectures. Again, it's just, we want to have a good effective model to start with, but we also want to have a low debug decay index that we can communicate and ask it like to fix things or debug with it more, so that it doesn't just fall. This is their experiment. They use the human eval. They look like this, where it's a little like leak code style thing. They have tests, they have unit tests. They have a canonical solution of like what a solution should look like. And here are their results for some of the models. I'll say that they do an R squared. So we said E naught is their initial effectiveness. Lambda is the debug decay constant that they've calculated. A naught is going to be their after debug steps, how many, the effectiveness. So like in this first one, Claude Sonnet solved all the problems in under 3 steps. So it didn't do it. The R squared is R squared statistics of how well it kind of like fits the model. So they say anything over 0.9, they made up these bounds, but anything over 0.9 is excellent. Anything between 0.7 and 0.9 is good, and anything under 0.7, they're gonna say it's poor, and you probably want a different decay function, or you want some other way of modeling this decay. But they have some smaller ones, like the code, well, this one's poor. Let's go. They have GPT-4 is also poor, but 3.5, they go from 70% effectiveness, so it gets 70% of the problems, and then given more debug attempts, it goes up to 85.9%. And they took a couple data points at different debug attempts. One thing I'll say about this paper is that it says that it only goes up to 6 debug attempts, but then they have here, it goes up to like 39 and 26 and 19 and 14. So they don't really explain that. But they definitely get some, some interesting, like it improves. You give it debug attempts, tries again, and it gets better. But you want to look for the ones with like lower lambdas. Like with high lambdas, it shouldn't get as much better. And then they just graph it, and they say that like after 2 attempts on some of these models, like on GPT-4, after 1 attempt, its effectiveness goes down to 50%. And after 3 attempts, it goes down to 80, like 20% effective, because it's 100 minus the 80. And so you could very quickly kind of asymptotically approach a garbage model or a garbage answer from what you're giving it. And so now that they have that and they've graphed these, they want to ask strategic fresh starts. As when is the best time to refresh this model instead? So the question is, based on the optimal debugging window identified in the research question 1 and the decay characteristics in question 2, to what extent can we implement fresh start strategies, reiterating the code generation process after reaching effectiveness thresholds, improve overall accuracy compared to continued iterative refinement within the same generated context? And so now they're going to do the same experiment, but they're going to just do it with at 50% effectiveness. They're going to just clear the context and re-give it the question, and then also at 80%. And here's the results on some of their models, and you can see that the dotted lines are the refreshes. They say that the spikes really show that it really helped that we refreshed it at 50% at 1 or 2 times, but it's always going to be more effective to refresh and to just start over than it is to continuously fall down the debugging hole of keep asking it to try again, try again, try again. And with the fresh start, they got better performance on all 6 model, no, sorry. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. They got better results on all models when they do the fresh restart as opposing to just keeping it, letting it try and try again. And that's something that, we've already known since the start of this talk. We said that you could just restart and try and get it better. But I think it's good that they're, making a metric of how it's working with people, because that's clearly how that's the best use case I've seen for all this generative AI stuff, is you use it with people, and we can start measuring that. They even say that they can reduce the tokens that you send to it. So this is tokens are money these days, where you can reduce your tokens, get answers quicker. So there you go. My own speculations from this paper, this is the end of it, is that they have used some of the models are much smaller. So I wonder how much of it is just context limits reaching and just model collapse from an overset, like a giant context window. Some of them were the bigger models, and you saw that they had like poor Art12, where Sonnet just solved all of them. Then is there prompt poisoning, that you kind of keeping your own errors in the context window? They just reused whatever the error was. They sent it back. They didn't give it any extra prompting to oh, go try something else. Forget that, try it again. But are you just poisoning your context window by kind of just telling it even though the whole thing was wrong, you kind of keep it in that window? And then one of the things I'll say is that if anyone uses Claude Code and sub-agents, and I think this is an argument for using sub-agents, is that the sub-agents will do these problems and they won't mess with your whole context window. So if anyone's vibe coded and you know that you've built up this beautiful, nice context, right, and it's great, and you don't want to lose it, but then you run into an error about some random thing that might not even be with your code, now you could just send it over to a sub-agent instead, so that you don't have to poison your own context window. And you can tell your sub-agent to do it. Try and go do it. If it can't do it, you just retry. You spin up a new one. You don't mess up your whole context window. That's kind of it. I know that was pretty fast, but yeah. Are there any questions?
Yeah, any questions for anyone? So we're just gonna.
You got a question?
One question.
I'm not sure if this is what you just explained, but relating to context windows and sizes, did they mention that we're going to fill it up with 20,000 tokens of context that's related to the project, and then start from there? Like you said, fresh start. So instead
Yeah, these are just like the leak code style problems that I showed for like a split second. So it's just the problem description, and it's no extra context on it. So they'll just restart with the exact same prompt. We got one more question.
It's a version of the same issue. Do you have any thoughts about why that happens? Like you have it really well trained, has the right context window, everything seems to be translating, all of a sudden it gets poisoned.
No, I don't know why. I think that's a big. I think that's the new as speculation. The models are getting marginally better. They're not getting as better as fast as before, but I think that the newest like low-hanging fruit is the context management, and like how we could better manage all of our context to give it the correct answer. They're stochastic models. Like I couldn't tell you why I wouldn't give you the exact answer. And then back.
I believe it has to do with k-nearest neighbors and multi-dimensional matrices. So you're talking about finance, and then you talk about Billy, who's your son. Those are two separate things, and it builds the context.
Yeah, I mean, there's a finite amount of attention that you can compute, and the more tokens you have, they get diluted out, right? So if you have a lot of detracting information or like previous bugs that you've done fixed, those bugs are still part of the context. So it's very similar to prompt poisoning. You're like prompt injecting yourself, basically. Cool. All right, thanks. So we're gonna just hang out here for another 43 minutes, and you can network, you can meet people, and hang out. And I'm gonna leave this up for a moment. So later this month, Thomson Reuters is doing a forum on September 25th. So if you want to join, this is mostly, especially if you work in the legal field, there's a lot of seminars and stuff that are talking about how agents are being used by law firms. So this might be interesting to you. But other than that, if you are interested in like giving a talk, especially if you want to do like a deep dive in a research paper or something that you've applied into production, please come talk to me. And thanks again to Capital Factory for hosting us.